Hello everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105. This video is all about the packet tracer of the chapter 3. Packet tracer investigating the TCP or IP and OSI models in action. So, the objectives of this packet tracer activity is part 1, examine HTTP web traffic. Part 2, display elements of the TCP IP protocol suite. So, the background. This simulation activity is intended to provide a foundation for understanding the TCP IP protocol suite and the relationship to the OSI model. Simulation mode allows you to view the data contents being sent across the network at each layer. As data moves through the network, it is broken down into smaller pieces and identified so that the pieces can be put back together when they arrive at the destination. So each piece is assigned to a specific name or the protocol data unit or the PDU and associated with a specific layer of the TCP IP and OSI models. Packet tracer simulation mode enables you to view each of the layers and the associated PDU. The following steps lead the user through the process of requesting a web page from a web server by using the web browser application available on a client PC. So, even though much of the information displayed will be discussed in more detail later. So, this is an opportunity to explore the functionality of packet tracer and be able to visualize the encapsulation process. So, the part 1, examine HTTP web traffic. In part 1 of this activity, you will use the packet tracer simulation mode to generate web traffic and examine HTTP. So, here are the simulation mode. So this one. So let's go to step 1. Switch from real-time to simulation mode. So we already switched to the simulation mode. So in the lower right corner of the packet tracer interface are the tabs to toggle between the real-time and simulation mode. So these are the real-time and simulation mode. Packet tracer always starts in real-time mode, in which networking protocols operate with realistic timings. However, a powerful feature of packet tracer allows the user to stop time by switching to simulation mode. In simulation mode, packets are displayed as an animated envelopes. Time is event driven and the user can step through network events. So, letter A, click the simulation mode icon to switch from real-time mode to simulation mode. So, we already clicked to the simulation mode. Then, B, select HTTP from the event list filters. So, edit filters. So, the HTTP, we will click the HTTP. Then, toggle the show all or /none checkboxes. Notice how the checkboxes switch from unchecked to check or check to uncheck depending on the current state. No? So, click the show all none checkbox until all boxes are cleared and then select HTTP. Click anywhere said edit box to hide it. The visible event should all so as we can see here, the event list filters. The only visible events is the HTTP. We'll go to step 2. Generate web HTTP traffic. Currently, the simulation panel is empty. There are 6 columns listed across the top of the event list within the simulation panel. As traffic is generated and stepped through, events appear in the list. The info column is used to inspect the contents of a particular event. Note, the web server and web client are displayed in the left pane. The panels can be adjusted in size by hovering next to the scroll bar while dragging left or right, then double-headed arrow. So, click web client in the far left pane. So, we will click the web client, this one. Then, click the desktop tab and click web browser icon to open. So, the desktop and the web browser. So, in the URL field, enter www.osi.local and click go. So, www.osi.local, then go. Because time in simulation mode is event-driven, you must use the capture or forward button to display network events. So here, click capture 4 times. There should be the event list. So there. Look up the web client web browser page. Did anything change? So we will see if there are any changes there. So wait. So there. Web server. You have successfully accessed the home page of the web server. So that is the changes that occur. So, step 3. Explore the contents of the HTTP packet. Letter A. Click the first colored square. So we will click the first colored square box under the event list info column. It may be necessary to expand the simulation panel or use the scroll bar directly below the event list. The PDU, so we will click here. This one is the first colored box. Then, the PDU information at device, web client Windows. There are only 2 tabs, the OSI model and the outbound PDU details. So these are the tabs, the 2 tabs. So the OSI model and the outbound PDU details. And then because this is the start of the transmission, as more events are examined, there will be 3 tabs displayed. Adding a tab for inbound PDU details. When an event is the last event in the stream or traffic, only the OSI and the OSI model and the inbound PDU details tab are displayed. So letter B. Ensure that the OSI model B. Ensure that the OSI model tab is selected under the Outlayers column. Ensure that the layer 3 box is highlighted. So we are in the OSI model tab. Then the layer 7 box is highlighted. So we are in the layer 7. What is the text displayed next to the layer 7 label? So that is that the HTTP client sends a HTTP request to the server. Then what information is listed in the numbered steps? So letter B, ensure that the OSI model tab is selected. Under the Outlayers column, ensure that the layer 7 is highlighted. So this one is the layer 7. Then what is the text displayed next to the layer 7 label? So it doesn't have text here, so it's none. Then what information is listed in the numbered steps directly below the in layers and out layers boxes? So this one, the HTTP client sends a HTTP request to the server. Then letter C, click next layer. Layer 4 should be highlighted. What is the destination port value? So next layer. So the destination port value is 80. Then click the next layer. Layer 3 should be highlighted. What is the destination IP value? Next layer. The destination IP value is the 192.168.1.254. Then, click new layer. Click next layer. What information is displayed at this layer? So, next layer. So the information is the next hop IT address is a unicast. The ARP process looks it up in the ARP table. The next hop IP address is in the ARP table. The ARP process sets the frame's destination MAC address to the one found in the table. The device encapsulates the PDU into an Ethernet frame. Then click the outbound PDU details tab. So here is the outbound PDU details tab. Information listed under the, so we can see here all the informations. We can see different information here. Then G is click the next colored square box under the event list info column. Only layer 1 is active or the not gray out. The device is moving the frame from the buffer and placing it onto the network. So the next, we will click the next colored square box. So this is the next colored square box. So advance to the next HTTP. So we can see here the device takes out the frame from the buffer and sends it. Fast Ethernet 0 sends out the frame. So advance to the next HTTP info box within the event list and click the colored square box. This window contains the in layers and out layers. So next, this one is the next. So here are the in layers and the out layers. Notice the direction of the arrow directly under the in layers column. So this is the arrow. So it is the upward arrow. And it is pointing upward, indicating the direction of the information is traveling. Scroll through these layers, making note of the items previously viewed. At the top of the column, the arrow points to the right. This denotes that the server is now sending the information back to the client. Comparing the information displayed in the in-layers column with that of the out-layer column, what are the major differences? So, we will compare the in-layers and the out-layers. So, let's start with the layer 4. So, the source port of this one is 1025. However, in the out-layers, the source port is 80. Then, in the in-layers, the destination port is 80. And the destination port of the out-layers is 1025. So, they exchange, or then the IP header source. So, the source IP of the in-layers is 192.168.1.1. While in the out-layers is 192.168.1.254. Then, the destination IP of the in-layers is 192.168.1.254. Then, the destination IP of the out-layers is 192.168.1.1. So, here, so we can see that they exchange their destination and the source. Then, click the outbound PDU details tab. Scroll down to the HTTP section. The outbound and the HTTP section. Here. What is the first line in the HTTP message that displays? So, HTTP data connection close. Then, click the last colored square box. Under the info column, how many tabs are displayed with this event and why? So, that's the last one. So, it has two. The OSI model and the inbound PDU details. Then, let's go to the part 2. Display elements of the TCP/IP protocol suite. In part 2 of this activity, you will use the packet tracer simulation mode to view and examine some of the other protocols comprising of the TCP/IP suite. So, step 1. View additional events. So, close any open PDU information window. So, we will close that. Then, in the event list filters, visible event section, click show all. Show all. What additional event types are displayed? So, there's various roles and TCP/IP of the. Then, click the first DNS event in the info column. Then the DNS. Explore the OSI model and PDU details tab and note that the encapsulation process. As you look at the OSI model tab with layer 7 highlighted, a description of the occurring listed below is in layers 1 so there, the DNS client sends a DNS query to DNS server. This is very useful information to help understand what is occurring during the communication process. So, letter D, click the outbound PDU details tab. So, click the outbound. Then, what information is listed in the name in the DNS query section? That is the www.osi.local. So, as we notice that this is the one that we typed in the web server a while ago. So, click the last DNS info colored box in the event list. Which device is displayed? This one. So, the question is, which device is displayed? So, the device is the web client. Then, letter F. Find the first HTTP event in the list and click the colored square box of the TCP event immediately following this event. Highlight the we'll just find the first HTTP. Find the HTTP. Highlight layer 4 in the OSI, the first HTTP. Then, layer 4 in the OSI model. So, the layer 4, this one. In the numbered list directly below the in layers, what is the information displayed and under items 4 and 5? So, the information is sent segment information, the sequence number 1, the ACK number 1, and the data length is 102. TCP manages the connecting and disconnecting of the communication channel along with the other responsibilities. This particular event shows that the communication channel has been established. So, letter G, the last one is click the last TCP event. Highlight layer 4 in the SI model tab. The last TCP event, this one, and then highlight layer 4 in the OSI model tab, layer 4 in the OSI tab, and then examine the steps listed directly below in layers and out layers. What is the purpose of this event? Based on the information provided in the last item in the activity, should be an item. So, these are the information are listed. Number 1 is the device receives a TCP push plus ACK segment on the connection to 192.168.254 on port 80. And number 2 is received segment information. The sequence number 1, the ACK number 103, and the data length is 272. Number 3 is the TCP segment has the expected peer sequence number. Number 4 is the TCP segment has the expected ACK number. The device pops the last sent segment from the buffer. Number 5 is TCP processes payload data. Number 6 is TCP reassembles all data segments and passes to the upper layer. So, to conclude this video, so we successfully make the connection, and we examine or investigate with, the TCP IP and the OSI model. So, thank you for watching.